Welcome to the discussion of general mathematics with topics covering functions as models and evaluation of functions. At the end of a discussion, you are expected to possess these knowledge and skills, such as demonstrate how function is being used in daily life, evaluate a function, create a model interpreting a piecewise function, and solve problems involving functions. To start, may I ask you one question? What output do you want to produce after taking this subject? Maybe you want to have a good grade. Then you need to exert more effort in studying this subject. Or you need to be more responsible in this subject. Don't worry, those efforts will be graded and appreciated, and you will have good grade in my subject. The same is true with our lesson now. Today, you will be exploring the relationship of the input and then the output. So, let's get started. First, we need to recall these terminologies in order for you to adapt with the new lesson. For the first term, set. It is a collection of distinct or well-defined members or elements. As an example, set of prime numbers. And they are 2, 3, 5, 7, 11, 13, and 17, and so on. So, elements are enclosed by braces and separated by a comma. It has well-defined elements because all members of should possess the characteristics of a particular set. Another example, set of alphabets, set of chairs, set of tables. Next, a relation in mathematics. A relation is any set of ordered pair numbers or a set of x and y, set of input and output values, set of independent and dependent variable. Example, -2, 3, our ordered pair of 4, 5, 6, -5, -2, and 3. It is also important to discuss the domain, which is the set of all input or first values of a function. Getting the example from relation, the domain is -2, 4, 6, and -2. That is all the x values from the given relation. Next, a range. Range of a function is a collection of all output or second values if the domain is a set of all input or first values of a function. The range is a collection of all output or second values. Again, getting the example from a relation, the range is 3, 5, -5, and 3. So that is our range. So relations actually and functions are one of the most important topics in algebra. In other words, we can define a relation as a bunch of ordered pairs. Input values are generally x values of a function. Output values are y values of a function. We can check if a relation is a function either graphically or by following the steps. Examine the x or input values and also examine the y or output values. Then, if all the input values are different, then the relation becomes a function. And if the values are repeated, the relation is not a function. So, what is a function? Functions in mathematics. A function is a relation between a set of inputs and a set of permissible outputs. Take note, a function is a relation, but not every relation is a function. Functions actually have the property that each input is related to exactly one output. That is, one-to-one correspondence and many-to-one correspondence can be the basis of knowing if a relation is a function or not. In the illustration, it is important to note that for each input returns a corresponding output. It is also necessary to discuss about the different types of correspondence, and it is best illustrated through the use of mapping diagram. In the given illustration, we have four types of correspondence. The first one is the one-to-one correspondence. It can be defined as each element of set X has a unique element on set Y. The second type of correspondence is many-to-one correspondence. Two or more elements of set X are related to one element in Y. The third type is one-to-many correspondence. In here, one element of set X is related to two or more elements of set Y. Lastly, many-to-many correspondence wherein two or more elements of set X are related to two or more elements in set Y. As you can notice, functions can only give one result for each input. Therefore, they only have one-to-one relations or many-to-one relations. For this illustration, one-to-one is a function and many-to-one correspondence is also a function, while one-to-many and many-to-many is not a function. For another illustration, so we have one-to-one correspondence, one-to-many, and many-to-one. For car company has unique car model. One doctor can be related to two or more patients, and two or more students are related to two or more subjects. Let us have this activity. Function or not function. Identify if each set of objects is a function or not. The variable x represents the input and the variable y represents the output. First, automobile to plate number. It is a one-to-one correspondence, then it is a function. Every automobile has a unique plate number. Math teacher to student in the class, it is a one-to-many correspondence, then it is not a function. One math teacher is related to two or more students. Next, zip code to residents of the town. It is a one-to-many correspondence, then it is not a function. Next, students to zip code. It is a many-to-one correspondence, then it is a function. Two or more students can have one zip code. Next, shoe size to students in the class. It is a one-to-many correspondence, then it is not a function. In this material, you will also learn the different types of presenting functions. First, functions as table of values. So let us use this function that we had in the function machine a while ago. F of x equals x plus 2. So here as you can see, you have here input of 3 and then output of 4. How is that? So in table of values, we have two sets. The set A and then the set B. So usually set of x, set of y. So for set A, set of x values. For set B, set of y values. Set A represents your inputs and set B represents your outputs. So set A will be your domain and set B will be your range. So remember that outputs will only depend on your inputs. So when you input different values into a function, you will get different outputs. So how is that? How to get these values from outputs? When you input 1, actually, into our function, f of 1 equals 1 plus 1, and your output is 2. Same with your input of 2. When you evaluate this, actually simply replace x by 2, f of 2 equals 2 plus 1, which is 3, and so on. That is our table of values. Next, functions as mapping diagram. So using again this table of values, set A for the domain and set B for the range. In mapping diagram, we use this shape, oval shape. We usually use this shape to present sets, set A and set B, your domain and your range, or your input values or your output values. So we also use arrow sign or arrow symbol to denote correspondence. So 1 corresponds to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, and 6 to 7. Next, functions as equation. Using again the function that we have in our function machine, f of x equals x plus 1. But since f of x is equivalent to y, it is logical to say that logical to have y equals x plus 1 using transitive property of equality. So when x is 2, simply replace x by 2, so y equals 2 plus 1, and then your y value now will be 3. When your x is 4, so simply replace x by 4, y equals 4 plus 1, your y is 5, and so on. Next, let us have this function as graphs. From this graph, actually you can tell if it is a function or not. So from the given table of values a while ago, 1 corresponds to 2, then 2 corresponds to 3, and 3 corresponds to 4, and 4 corresponds to 5. Next, let us now proceed with functions as models. So function is often used in interpreting scenarios in life into mathematical models, mostly called function models. These function models lead us to a better understanding of various occurrences. So let us take this scenario. 5 students from STEM 11B list down their grades in general mathematics. Basically, each student has only one grade for general mathematics, but more than one student can get the same grade. I will use mapping diagram in representing this scenario. For set A, name of students, we have 5 students, namely Grace, Ivy, John, Neil, and Erica. For set B, grade of students. So this will be our output or y value. So as you can see, Grace got 90, Ivy got 89, John got 94, Neil 90, and Erica got a grade of 92 in general mathematics. Now, let us answer these questions. Is it logical that each student gets only one grade? I think it is logical that one student can only get one grade for each subject. Is it also logical that more than one, say many students can get the same grades as the others? I think it is also logical. Erica can get 90, same with Neil and Grace in general mathematics. Is it possible that one of your classmates does not have a grade in general mathematics? Logically speaking, all students who are enrolled in a particular subject ought to have a grade, may it be a failing grade or passing grade. So, no, it is not possible. How do we represent this scenario into function? Model as x be the name of each student and y be the grades of students. So we have this function model as y equals x. So when your x value is Grace, your y value is 90. When your input is Neil, your output is 92, and so on. Next, let us proceed with the functions as models. So let us have this real life situation. Aling Kising delivers meals that cost 45 pesos to her customers daily. If she delivers X number of meals in a day, represent her total earnings as E of X. Remember that your input or your X value is the number of meals, and your Y output or Y value or your E of X will be your total earning in a day. Example, Aling Kising delivered 40 meals in just one day. So, what will be her total earning? So, her total earning will be 40 times 45 is 1,800. And how to translate that into a mathematical equation? So, when your X, which is the number of meals, is 40, your Y, which is your total earning, will be 40 equals 40 times 45. So in mathematical symbol, we have Y equals X multiplied by 45. 45 will be your constant number because it does not change, while X is your input, which is independent or which is changing, and your Y just depend on the number of meal delivered by Aling Kising. So since Y is equivalent to E of X, we have E of X equals 45X. So we used to have numerical or number first before the variable. So X multiplied by 45 is 45X. Using this function, E of X equals 45 multiplied by X. What if Aling Kising delivered 100 meals in just one day? Then replace X by 100. So E of 100 equivalent to 4,500. So the total earning of Aling Kising is 4,500 if she delivered 100 meals in just one day. And that example is a linear function. Now, we will now be discussing about piecewise function. Piecewise function is defined as a function that is defined by different formulas or functions for each given interval. And the function is defined by pieces of functions for each part of the domain. So this is an example of a piecewise function. Actually, it is just a function with three different formulas depending on some rule or condition set in our domain. So in a piecewise function, the input actually is divided into pieces of a formula with each piece. So here, for x greater than 0, we use a function f of x equals 2 times x. For x equals 0, we use a formula f of x equals 1. And for x less than 0, we use a formula f of x equals negative 2x. So here, the input is divided into pieces of a formula with each piece having their own condition or rule to deduce the output. It shows a different interval that behaves differently. We actually apply piecewise functions in our lives more than we think so. Tax brackets, estimating our mobile phone plans, and even our salaries with overtime pay make use of piecewise function. And to read this, when x is greater than 0, f of x is equal to 2 times x. When x is equal to 0, f of x is equal to 1. When x is less than 0, f of x is equal to negative 2 times x. So how to evaluate piecewise functions? So let us answer this scenario. A mobile phone company offers the following plan. 400 pesos per month for 60 minutes of call. Additional time costs of 4 pesos per minute of call. So we can use T as a variable representing the number of minutes, and C of T for the cost of plan per month. What if you consume only 40 minutes? How much will you pay for your mobile phone? So C of T equals 400. Why? Because the plan is to consume 60 minutes. Since you consume only 40 minutes, you will pay for only 400 pesos, or you will pay still for 400 pesos. What if you consume 140 minutes of call? How much will you pay for your mobile plan? So C of T equals 4 times 140 minus 60 plus 400. Why? Since you have other formula or other payment, if you consume 60 minutes, so you will just less 60 from 140. So 140 minus 60 is actually 80. So 80 minutes of call is the additional minute, and each minute will have additional time cost of 4 pesos. So 4 times 80, which is 320, plus 400, which is the constant value. So 320 plus 400 is 720. So when you consume 140 minutes of call, you will pay an amount of 720 pesos. Okay, now let us answer this given scenario using piecewise function. As you can see, we have two conditions, so we have two formulas for piecewise function. So for the first, 400 pesos per month for 60 minutes of call. So we have the C of T equals 400. When your time is less than or equal to 60, but more than or equal to 0. Another formula, when your time is greater than 60, you will use a formula of C of T equals 4 quantity T minus 60 plus 400. And that is how we divide the domain, and that is how we create different formulas for a different situation or cases. We use T, we represent the number of minutes as T, and C of T cost of plan per month. When you consume 40 minutes of call, you will still pay for 400 because T equals 40 is within the interval of 0 to 60. So your payment will be 400 pesos. When your T is 140, it is you will use a second formula because 140 is greater than 60. So C of 140 equals 4 times T minus 60 plus 400. So since T is 140, so 4 times 140 minus 60 plus 400. Simplifying that, we come up with C of 140 equals 720. As you can see, different output from 400 because we have different input, which is 140. Next, the cost of hiring a catering service to serve food for a party is 150 pesos per head for 20 persons or less. 130 pesos per head for 21 to 50 persons, and 110 per head for 51 to 100 persons. For 100 or more persons, the cost is 100 pesos per head. Represent the total cost as a piecewise function at the number of attendees of the party. We use X as a number of attendee, and f of x, total cost of hiring a catering services. So f of x, since we have 4 conditions, so we have 4 different formulas. So the domain will be divided into 4. For 0 to 20, 150 per head. So x is represented by the number of attendee. For 21 to 50 attendee, that is 130 times x, because the amount of payment per head is only for 130 pesos. For 51 to 100, it is 110 times x, and if it is above 100, the payment per head is 100 pesos. So 100 times x. So using this formula, what if your attendee is only 11? So we will use the first formula because 11 is within an interval of 0 to 20. So f of x equivalent to 150x. So evaluate this, simply replace or substitute x by 11. So f of 11 equals 150 times 11. Simplifying this, we have 1,650. So when the number of your attendee is 11, the total cost of hiring a catering services is 1,650. When your attendee is 100, the number of your attendee is 100. So we will use actually the third formula because it is within the interval of 51 to 100, included yung value ng 100. So simplifying those, 110 times 100 is simply 11,000. So you will pay for an amount of 11,000 in a catering services. To end this topic, I want to share you this one simple thought. In life, they say what you sow is what you reap. That is, if you want to have good grades, you need to exert more efforts. And if you want to finish your study, you need to study well. Remember that life is a process of becoming what you want, and it will all depend in your actions and behavior. So, choose and take the right actions and behavior to achieve the person you want to be. And these are my references in creating this material. Thank you to Boundless.com, Verzosa, and Mastin. Again, thank you for listening. God bless, and please be COVID-free.